Hello, everyone, and welcome back to Indian Genes. As part of our ongoing Season 2, 2021 A New Dawn, things are getting really interesting here as we look into various aspects of space exploration and try to address the questions that inevitably come up. So, today we discuss a topic that most of you have been asking us to take on, with Perseverance now on Mars trying to answer the question of is there or was there life on Mars? Our guest today takes this one step further, asking a very interesting question, which is, have we been visited by extraterrestrial life? And speaking to us today is a professor of science at the Harvard University and was subsequently a long-term member of the Institute for Advanced Study at Princeton. He has been the longest-serving chair of Harvard's Department of Astronomy and a founding director of Harvard's Black Hole Initiative. He was also elected fellow to the American Academy of Arts and Sciences and the American Physical Society. He is a former member of the President's Council of Advisors on Science and Technology at the White House and also chairs the advisory committee for the Breakthrough Starshot Initiative. In 2012, Time magazine selected him as one of the 25 most influential people in space. His new book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, is an absolute must-read. In this book, he takes readers inside the thrilling journey of the first interstellar visitor to be spotted in our solar system. He outlines his controversial theory and its profound implications for science, religion, and for the future of our species on our planet. This is a mind-bending journey to the furthest reaches of science, space-time, and the human imagination. Indian Genes is proud to bring you a very exciting conversation with an extremely interesting person, none other than Professor Avi Loeb. Hello, Avi. It's an absolute honor to have you speak to us here in India, exclusively through Indian Genes. We do know that your time is limited. You have an interview with CNN coming up, and we will have to release you on time. But before we get into that, first of all, it's an absolute pleasure to have you here, and thank you for talking to us on Indian Genes.
Thank you for having me.
Thank you. And before we start, and I think probably the best place to start, if that is okay with you, is in the eye of the storm. And there seems to be a storm and there seems to be an eye here, right?
Yes, if you refer to the response of the media and the public, as well as the scientific community, there is a lot of attention to my book. And the way I view it is as a platform for me to convey my views about things that are not necessarily healthy right now in the academic culture, but also to advocate for being open-minded about the possibility that we might not be alone, that in fact we might not even be the smartest kid on the block.
True, that has been, funnily, there are a lot of people outside science. And when I say outside science, I count myself there because I am a communicator. But most of the people I interact with strongly believe in a lot of this, strongly hold views that it is possible, and everyone seems to be very enthusiastic about it. But
Yes,
I was quite surprised to the reaction, honestly, from the community.
Yes, currently we know, thanks to the Kepler satellite, that a substantial fraction of all the sun-like stars, about half of them, have a planet the size of the Earth, roughly at the same separation. And that means that the physical conditions on the surface of those planets would be quite similar to what we find on Earth. And if you repeat similar circumstances, you're likely to get similar outcomes. Therefore, in my view, given what we know now, it should be mainstream, it should be common sense to assume that there are many life forms similar to us around other stars. That should be the starting point. And from that, we should decide to search for either primitive forms of life or intelligent forms of life. And it's not clear which one is easier to detect. Because let me give you an example. The astronomy community is planning to invest billions of dollars in the future decades to search for oxygen in the atmospheres of planets around other stars. The idea is that oxygen may be indicative of life. The problem with that notion is that for 2 billion years, the Earth did not have much oxygen in its atmosphere, even though it had microbial life. So, not finding oxygen is not necessarily an indication that there is no life. For half of the lifetime of Earth, there wasn't much oxygen in the atmosphere. But even if you find oxygen, it may not indicate life because you can make oxygen by natural chemical processes. So, what would be an indication of life? Without a doubt, after investing those billions of dollars, it would be if we use the same telescopes, the same observatories, the same instruments to search for industrial pollution. Because these molecules are not produced by nature, and if we find them in the atmospheres of other planets, they would imply that not only there is life there, but there is industrial life, technological life. And so sometimes, under some circumstances, it may be even easier to detect intelligent life than microbial life and more conclusive. So, my point is we should be open minded, we should take advantage of all the instruments and the telescopes that we are developing and search for other kids on the block. There is nothing more exciting than that. And the public is extremely interested in this question. The public funds science. So, how can it be a situation where the scientific community shies away from any discussion on technological signatures and puts a taboo and ridicules whoever raises a possibility that something anomalous that was found may be a technological signature?
Absolutely. And you mentioned biosignatures or microbial life. Even having found those, that still, like you have just said, doesn't indicatively give you any proof that life would have developed or has developed and moved on. But a direct industrial signature, if you can call that, or artifact would be much more exciting.
That's right. And speaking about searching for technological signatures, in the past, we focused on radio signals. And that started about 70 years ago when we developed radio for communication. That requires there to be someone on the other side that is alive. It's just like speaking on the phone. In order to have a conversation, you need the other side to be alive. But if you imagine another form of communication, letters, if you get a letter in the mail, the sender may not be alive, doesn't need to be alive. And so looking for messages in a bottle, or as I call them, technological relics that are floating in space and were produced by civilizations that might be dead by now, is another approach. And that seems to me more promising because it sums over a long history of billions of years when civilizations could have been around and they might not be around anymore. So it's just like doing archaeology, where you find relics of past cultures that existed on Earth. For example, the Mayan culture does not exist anymore, but we know that they existed because we find relics in archaeological sites. So we can do archaeology in space and search for technological relics, either floating in space, like Oumuamua perhaps was, and that's what I describe in my book, or on planets. You can look for industrial pollution, you can look for structures and photovoltaic cells, or maybe even artificial lights that were turned on but not turned off after the civilization was gone from there.
Right. And coming to Amuwa Umua, which I assume is a Hawaiian name for a scout, very aptly. Would you want to just explain to a lot of our listeners what got your attention initially and how did this whole thing play out?
Yeah, so this object was the first interstellar object that was spotted close to Earth. And by interstellar, we mean objects that came into the solar system from outside. And it was discovered in October 2017 by the Pan-STARRS telescope in Hawaii. And that's why it was given a name that means something in the Hawaiian language, Oumuamua. And at first, of course, astronomers assumed it's just a rock, similar to all the rocks that we have seen before within the solar system, like comets or asteroids. A comet is a rock that is covered with ice, and when it gets close to the sun, the sunlight warms it up and evaporates the ice into a cometary tail. So we see these beautiful trails of gas and dust behind comets. The only problem was Oumuamua didn't show any cometary tail. So, we would have naturally expected it to be a comet because these are the most abundant objects in the solar system. They extend all the way out to the edge of the solar system in the Oort cloud, and they can easily be ripped apart from the solar system by passing stars. And so if you imagine other stars having Oort clouds, you can assume that most of the interstellar objects will be comets. But Oumuamua was not. It didn't have any cometary tail. And in fact, the Spitzer Space Telescope looked very deeply around it and put very tight limits on carbon-based molecules or dust. So it was definitely not a comet. And then people said, okay, well, maybe it's just a rock. This object, as it was spinning around or tumbling over 8 hours, showed big variations in the amount of reflected sunlight, variations by a factor of 10. And that means that the area that the object occupied on the sky was changing by a factor of 10 or more. And it means that the object was at least 10 times longer than it was wide, projected on the sky. And the best model to fit the variations in the light curve was that of a disk or a pancake, something flat, not cigar-shaped the way you see in one of the famous cartoons. Projected on the sky, it looked like an elongated shape, but it was actually a pancake shape, flat. And then the most strange thing about it is that it exhibited an extra push away from the sun. And this extra force that was acting on it, in addition to gravity, was declining inversely with distance squared in a very smooth way. So the only thing I could think of that would do it was reflected sunlight. When sun bounces off a surface, it gives it an extra push, sort of like wind bouncing off a sail. In order for the effect to be significant, you need a large area per weight. And that meant that this object needs to be very thin, just like a sail on a boat. And we call it a light sail. And this is a technology that we are currently developing for space exploration. It offers the advantage that the spacecraft does not need to carry the fuel with it. And so I suggested in a paper, scientific paper, that with my postdoc Shmuel Bialy, that perhaps Oumuamua was a very thin object, a light sail. And as it turns out, in September 2020, just a few months ago, there was another object that exhibited an extra push from reflected sunlight and didn't show any cometary tail. And it turns out that this was a rocket booster from a 1966 mission to the moon, Lunar Lander Surveyor 2. And it was very thin and hollow, and that's why it exhibited this extra push. So that shows we can tell the difference between a rock and something thin. And in the case of this rocket booster, we know that we produced it. We know that it's artificial. In the case of Oumuamua, we don't know who made it.
Right. And I think, interestingly, one of the pushbacks to your observation was Borisov. I think that was another object. And just because of the fact that it turned out not to be any alien form of or any artificial form of an object. So was that used against your description or argument?
Well, so that was the second object discovered, discovered by a Russian amateur astronomer, Gennady Borisov, and it's called Borisov. It looked just like a comet, a regular comet, the way we expected the first one to be. And so people, as I mentioned in my book, people approached me and said, doesn't that convince you that Oumuamua was also natural? And I replied that when I met my wife on the first date, I thought that she's special and unique. And the fact that I met a lot of people after that did not change my opinion about her. So if you find a lot of rocks and seashells on the beach and they all look natural, but then you stumble across a plastic bottle and it looks as if it came from a civilization, then the fact that you saw rocks many of the times does not mean that the plastic bottle is natural.
Mm. And you said it was discovered in 2017. Did we discover it on time, or was there anything we could have done if we would have discovered it earlier, or was
Yes.
it just passing by and nothing we could do?
Well, of course, it would have been much better if we discovered it a few months earlier, because in October 2017, it was already moving away from us. So it's sort of like having a guest for dinner and realizing that the guest is interesting when the guest leaves through the front door into the dark street. And we couldn't really chase it because it was moving too fast for our rockets. By now, it's 1,000,000 times fainter than it was close to the sun. So we can't really continue to observe it. And if we were to discover it, for example, in July instead of October, we would see it coming towards us. And at that point, we could have even launched a spacecraft with a camera that would wait for it along its journey, and we could have taken a close-up photo. As they say, a picture is worth 1,000 words. And if we had a photograph of this object and it didn't look anything like a rock, that would have convinced everyone that it's artificial. And that's what we should do for the next one that we find that looks as weird as Oumuamua. And I'm optimistic that in a few years we will find many more. That's based on my experience when I go to the kitchen and I look at the cabinet and I see an ant. I get alarmed because I know that there must be a lot of other ants hiding somewhere or around the kitchen. And so we are likely to find more. We just surveyed the sky with Pan-STARRS for a few years and found this one. And then when we find more, if one of them approaches us, we can get a much better view of it, hopefully with a camera that passes by and takes a close-up photo. And I should say that in July 2017, by coincidence, I visited Maui in Hawaii and went to that observatory where Pan-STARRS is to give a seminar. I was on vacation with my family. Back then, nobody knew about Oumuamua.
That is so interesting because is what SETI doing at the moment, do we expect something similar to happen? But because you said we initially started with radio waves. So for people listening to us, a lot of us think that probably SETI is something that is going to find some signal. But obviously what you're saying is we need to do more.
Oh, definitely. And a completely different approach, searching for objects, physical objects, which is similar to archaeology. So I call it space archaeology. And it's completely different from searching for radio signals, both in terms of the requirements on the sender of those signatures. In the case of a radio signal, the civilization needs to be alive. In the case of relics, it doesn't. And the Drake equation is often used in the context of radio signals, and it basically encapsulates our ignorance. There are several factors in it. Depending on your assumptions, you get a different chance of detecting a radio signal, but it doesn't apply to physical objects. For physical objects, think of it as space trash, as objects floating in space. For example, Voyager 1, Voyager 2, New Horizon are objects we sent out that will leave the solar system. And although now they are still functional, think about what will happen to them in 1,000,000 years or in 1 billion years. They will be just space junk. They will not operate anymore, floating through space, and someone could find them. And the only question as to whether we will find space junk is what is the abundance, what is the number of such objects per unit volume that is moving randomly through space. And if we search, we might find them every now and then. And that's a completely different calculation than the Drake equation. It's just a question of how many per unit volume we can find in our neighborhood. It's similar to saying how many plastic bottles per unit area you have on the beach. You go around, you see a lot of seashells and rocks, but every now and then you find one of them. And these plastic bottles are not functional anymore, but they clearly indicate that we know that nature cannot produce plastic.
Right. And I think you very, very interestingly and very well, I should say, in your book and the paper that you released in 2021 January, where you speak about scientific results must be reproducible. A lot of people listening to us here are university and college students, and they want to get into research and fields of research. What would you say to them if they had to, because not many people either have the courage to get into this or are held back for whatever reason?
Well, so that's the main reason that I speak out, because I don't have to worry about, I have a tenured appointment at Harvard University. I also have a leadership position. I was department chair for 9 years of the Harvard Astronomy Department. It was renewed twice, and I was the longest serving chair. I'm the chair of the board on Physics and Astronomy of the National Academies. I also chair the advisory board for the Breakthrough Starshot project. So I have a lot of leadership positions. And in that capacity, I feel confident that I can speak out. But I know that the younger people are worried because this subject is not at the mainstream, and they can be perhaps not have as many opportunities for jobs if they were to deviate from what the majority of the community is doing right now. So my goal is to bring it to the center of the mainstream, because that's where it belongs, this subject. The public is interested, the public funds science, it should be there. We have the ability to address this question. And frankly, we are doing things that are far more speculative right now. For example, most of the matter in the universe is not known. It's called dark matter because we can't see it. And over the years, there were suggestions for different types of particles that could constitute the dark matter. And people built experiments that search for specific types of dark matter, like weakly interacting dark matter, WIMPs, or axions, or all kinds of others. And hundreds of millions of dollars were invested in those experiments. Nothing was found. We just have better limits. Many of the original suggestions are ruled out by now. Now, this is part of doing science at the frontier. Sometimes you go in directions that do not lead anywhere. But these directions, are really in the dark. It's the dark matter. We don't know what the dark matter is, and we are going in different directions. Now, why would that be considered part of the mainstream, whereas searching for technological signatures of other civilizations would not? I would argue that the search for dark matter is even more in the dark. We have no clue as to what the nature of the dark matter is. I mean, we have some general ideas, but we don't know what it is. It could be black holes that were made in the early universe, and then we will find nothing. It could be that gravity is modified, and then we will find nothing. But it's part of the mainstream because we feel it's an important question that we should address, and we should try various options. Now, exactly the same approach should apply to the search for technological signatures. And in fact, it's even less speculative there because we know that we exist, and we know that the conditions we have on Earth are replicated in many other places. So I would argue that the mainstream community in astronomy is currently exactly on the opposite side of where it should be. This should be part of the mainstream, and it is being put in the periphery. And through my book, through my voice, I'm trying to change this situation and bring it to a healthy place. I think part of the problem is that people in general, not just scientists, prefer to think that we are unique and special. It flatters your ego to think that you're special and unique. And it started with the Greek philosopher Aristotle, who said that the earth is at the center of the universe. And everyone agreed with it for 1,000 years because it flatters your ego to think that you're at the center of the universe. My daughters, when they were infant, they thought that they're at the center of the universe because their universe was just home, and they were at the center of the family, and they thought that they're at the center of the entire universe. So that's quite natural for a naive perception, and it flatters your ego. But then my daughters went to the kindergarten and saw other kids, and they got a better perspective about their place. They realized that they don't have the best qualities. And so we realized that we are not at the center of the universe with Copernicus and Galileo. At first, when Galileo made this point, philosophers did not want to look through his telescope. They just put him in house arrest. It was threatening their ego. But it didn't change reality. Reality is whatever it is, unrelated to whether you ignore it. And so the Earth continued to move around the sun, even though the philosophers didn't want to believe it. And eventually, this just maintained their ignorance for a while, but eventually we found out that we are not at the center of the solar system. The Earth is moving around the sun, and the sun is moving around the center of the galaxy. And the galaxy, the Milky Way, is just one of 1 trillion galaxies in the observable volume of the universe. So really, there is nothing special about our location, nothing privileged. We're sort of in an average place. And people still prefer to believe, even though that we are we learn that we are not at the physical center of the universe, people still want to maintain that we are at the center of the biological universe, that we are special and unique. And they ask for extraordinary evidence to demonstrate to them that we are not the only ones. And I ask you, isn't that similar to what Aristotle was arguing? Like, we are special and unique, we are privileged, and show me evidence that we are not. And we've learned through history that we are never in a privileged place. The Earth-Sun system is not privileged. There are almost half of the sun-like stars have such an Earth. And so even our backyard looks similar to all the other backyards. And why would we believe that we don't get the same outcome? So I would argue that a much more natural thing to assume is, let's be modest. Let's assume that we are typical, and then just search for those signatures. And that should be the natural point of view. The other thing is, there is this literature on science fiction that is not rooted in science. And there are reports about unidentified flying objects that are, doubtful. And so scientists say, we don't want to deal with that subject. And my reply is that in the Middle Ages, in the Dark Ages, there were people saying you should never dissect the human body because it has magical powers. There is a soul. You should never enter into the human body. And imagine if scientists would say, okay, there is all this nonsense being said about the human body. We don't want to operate people. Where would modern medicine be? Science should address every subject if it has the ability to do so with the scientific tools, because that improves our knowledge. We want to figure out what things are. So how can the scientific community say, there is nonsense being said about aliens, therefore we don't want to deal with this subject? Makes no sense to me.
Absolutely. You mentioned about dark matter, and maybe one of the thoughts that come to my mind is, if mathematics is the universal language, and then we attach that to some kind of theory because it works in mathematics. I could think of a multiverse. So that is similar. It could work in a mathematical theory on the board, but since you mentioned dark matter, it's the same case with the multiverse, right? We'll never be able to prove it.
Yeah, no, in fact, so this is another aspect of my frustration, that you find in theoretical physics right now a focus on subjects that have no experimental test. So the one thing that Galileo pioneered is the scientific method, where you test your ideas against evidence. Evidence is really key to science. You need experimental feedback because physics is a dialogue with nature. It's not a monologue. We're not telling nature what it should be. That's what the philosophers thought, that they tell nature, you should be centered around us. But we can't, we should be modest. Nature is whatever it is, and we should figure it out. And we do it by allowing nature to tell us something through experiments. So we get data, and then we analyze it, and we learn something new. Nobody would have expected quantum mechanics. It was completely non-intuitive. And Albert Einstein resisted the idea that quantum mechanics has spooky action at a distance, and he was wrong. So here again, experiments taught us that our preconceptions are wrong, and sometimes nature's imagination is far greater than ours. So out of humility, we should allow nature to tell us the answer rather than say that we know it in advance. Now, the problem in theoretical physics now is, for decades, there was no new experimental feedback that guided the theories. And so they started going in directions like extra dimensions, superstrings, the multiverse. These are ideas that have no contact, no connection to experimental verification. And yet they are celebrated by the mainstream. And people give each other awards for mathematical gymnastics on these concepts. Now, this is, I think, a betrayal of the tradition of physics. And the way I understand it is, in academia, many people want to just demonstrate that they are smart. That's their objective. Not to understand nature, it's to demonstrate that they are smart. And in order to demonstrate that you're smart, you can define a subject. In fact, it's better not to show any skin, not to take any risk by comparing your ideas to experiments, because then you might be wrong. So if you want to maintain a very strong image that makes no mistakes, you just work on mathematics. That will never be wrong if you do it right. And nature may have nothing to do with it. But as long as there are no experiments, you're on a safe ground, and you can be in your comfort zone and demonstrate that you're smart. And that's pretty much what's going on right now in theoretical physics in the area of string theory. They work on subjects that have no connection to data, to experiments, and moreover will have no connection, because some of these spaces that they work in, like anti-de Sitter space, is not the one that we live in, but that's where they enjoy doing the mathematical gymnastics. And they claim, I have no problem with people working on mathematics, but they claim that they carry the torch of physics forward. And that's a wrong statement, because they have no contact with experiments. And I ask you, how is it possible that mainstream physics is engaged in discussions about concepts that cannot be tested experimentally? They represent a betrayal of the tradition of physics, and at the same time, a subject that is based on evidence and very much rooted in our experience of searching for other civilizations on other planets, just because we exist, and just because the conditions on so many billions of planets are similar to those on Earth. That kind of a subject is considered speculative. How is that possible, to have these two situations at the same time? And I think that something is completely twisted in the academic culture right now, which is focused on the ego of individuals rather than on understanding nature. Sometimes nature is simple. You don't need mathematical sophistication. You don't need to work in spaces that do not exist. You just need to figure out what nature is, and that's it. And it's simple. And it doesn't need to show that you are smart. You just need to find out what it is. And that's a completely different goal than demonstrating that you are smart. In the Olympics, people decide 100 meters is the distance that will measure whether a sprinter is fast or not. Now, this 100 meters is just arbitrary, right? It has no significance whatsoever. It could have been 50 meters, could have been 150 meters, whatever. Doesn't matter. You check whether a person runs fast. And I see much of this intellectual gymnastics as a way to measure how smart people are in academia. But that should not have been the goal. The goal should have been, let's understand what the world around us is. And that's a different goal.
What it reminds me of is events seem to be cyclical, and human behavior tends to have a lot of patterns. So what we're talking about now is probably, I would look at it as, prior to 1995, people who were talking about exoplanets would have been looked at the same way. But today, every day I open my phone, I get to know there's a new exoplanet discovered.
That's right. I had the benefit of working on frontiers when they were young and pioneering some of them. And I noticed the same resistance of the mainstream community. And then after a while, they accepted it. And once it became mainstream, then of course the younger people that entered those fields said, "Oh, I can't believe it was never like that." And in the example of exoplanet is actually a very good one, because in 1952, Otto Struve, an astronomer, wrote a paper saying, we should search for Jupiter-like planets close to a star, because if they're close enough, they would move the star back and forth. We could easily detect that, or they will have a high probability of occulting the star, coming in front of it, so we can see the deficit in the brightness of the star from the passage of the Jupiter in front of it. And he was just suggesting that. And for 40 years, for 4 decades, astronomers didn't want to allocate telescope time to do that search, because the argument was, we know that Jupiter in the solar system is much farther out, than needed to detect such a system, and therefore, we understand also why Jupiter is so far out, and therefore there shouldn't be any such systems. It would be a waste of telescope time to even check. And then in 1995, the data on one such system came back and showed that there is a system. And for that, the Nobel Prize was awarded a few years ago. And you might say, oh, but no harm was done. Eventually science converged on the right answer. Well, this baby took 4 decades to be born. And science would have made much more progress if we were to discover it 4 decades earlier. It's just the efficiency of science making discoveries was reduced by the resistance of the community to allocate a little bit of telescope time just to search for such system. What's the big deal? We use telescopes for many other things that don't give any exciting result. Why couldn't we give 10%, 15%, 20% of the telescope time to risky propositions of this type? And it would have made science much more efficient, healthy. But the other thing I say, this is a baby that was born 4 decades later. But think about all the babies that were never born. For every baby that was barely born after 4 decades, there must be many more that were never born. And we lost that. All these ideas that could have brought to life new frontiers in science, how many of these were lost because the mainstream community was stubborn, insisting on paradigm and not willing to entertain ideas that deviate from the mainstream? And at the same time, you see the mainstream in particle physics going crazy in directions that were not testable, that will not be testable in the next millennium. I don't know when they will be testable. And there are even philosophers supporting them and saying, oh, we need to rethink physics. Maybe experiments are not really needed. Well, the truth is, Aristotle thought that way as well. But then Copernicus and Galileo taught us that, the idea that we had was wrong based on data. And so we now know that we really need feedback from reality. It's sort of like, some people saying, oh, we can stay high on drugs and enjoy something that we imagine, which is beautiful, and that's just like thinking, oh, I might be more wealthy than Elon Musk. I have a lot of money in the bank. And that's a beautiful thought, and until you go to the bank and you check how much money you have and you realize that you don't have much. And so the going to the bank is equivalent to doing an experiment. You can have beautiful ideas and they would be very appealing. The spheres around us in Aristotle's view of the universe was beautiful and very sophisticated and showed that Aristotle was smart. It was just wrong. That's all. It was beautiful, but wrong. And how did we find out? By actually doing observations through Galileo's telescope. And the point is that, nature is whatever it is. We can stay ignorant. I have no problem. If you want to be ignorant and happy, that's fine. That's what animals do. They can be happy and completely ignorant. But humans are different than animals. I think humans want knowledge. And knowledge means that you need to find the truth about reality, about the world, and not just enjoy beautiful thoughts.
So true. And you mentioned Aristotle. Would it be one of the reasons that early science started with philosophy, or the earlier scientists were philosophers, and we've reached a stage where we still are connected in some way? Or do you think that that connection needs to be cut and these two need to be looked at as two different fields?
Oh, no, I think, philosophy can be thought of more the embryonic phase of science, because, even Einstein, when he tried to come up with his theory of gravity, he went back to some philosophers like Mach and others that, thought about the basic underlying principles that guided Einstein. And I think when you're trying to create a better understanding of nature, you many times you go back to the board and think more abstractly about the possibilities, about what's the best path to take, and at that point it's not very different from doing philosophy. So I would say, in general, I would say that the humanities are really important. There are many scientists and people that work in the tech business that completely dismiss the significance of the humanities, and humanities are in decline. Philosophy, arts, and so forth. Fewer young people are attracted to that because there are not many job opportunities. But think about all the technologies that we are developing right now, like artificial intelligence or DNA studies, and in these areas, the ethics is extremely important. So, for example, artificial intelligence may be crucial in making decisions, life and death decisions about medical situations in the future. And when you don't have a doctor, a human involved in the decision making, when it's a computer, there are lots of moral questions, ethical questions, how to do it in a way that would be humane and would be guided by our ethical principles. And here, the humanities philosophy is important. And similarly, in the context of genetics, there would be the ability, now that we understand the human genome, the ability to perhaps design some qualities that humans may have. And you have to decide about the boundaries of doing that. Just like when we figured out the atomic secrets and developed atomic weapons, there were issues to do with how to use them. And so science and technology unleash new forces, and we really need the humanities, the philosophy, to guide us.
Coming to your book, I have to say that you have a very, very exciting cover. And I was looking when I got it, and strangely, I just wanted to ask you about that. It's a young boy looking up into space, and there's a beautiful globe or a moon behind in the background. And does that signify what you're trying to get across? As we grow older, we tend to stop thinking or taking risks, and we are full of wonder while we are young.
That's right. But I should say, don't judge a book by its cover. The cover and the title were selected by my publisher. I focus on the content. And it's true that there is something to the cover that reflects the way I think, because I pretty much want to stay genuine, similar to the way I was in my childhood, because I remember that very fondly as a kid. I was wondering about the world. I wasn't very occupied with my ego, and I was willing to take risks and make mistakes. And I was asked, for example, by the Harvard Gazette, the Pravda of Harvard, the official newspaper of Harvard, to answer one question: what is the one thing that you would like to change about the world? And my answer was, I want my colleagues in academia to behave more like kids, in the sense of being guided by their wonder, less by their ego, not building these echo chambers that amplify their voice of students and postdocs, and not trying to get honors and awards, taking risks, making mistakes. That's part of the learning experience, especially after you have tenure in academia. That is a privilege, that you can do whatever you think is right without worrying about your job. And unfortunately, many of my colleagues do not take advantage of that. So coming back to the cover, a boy looking at the sky is pretty much what I am. I am still a farm boy. I was born on a farm and used to collect eggs. Every afternoon we had chickens, and I used to drive a tractor to the hills of the village. I was born in Israel. And I very much remain the same person. If you ask people that know me, I haven't changed much, and I don't want to change. Even though I have all these titles of professor, tenured professor at Harvard, chair of the astronomy department, and director of this and that. These are just titles. These are just like the cover of a book. It doesn't mean much to me. It's the content, the substance that matters. And I really enjoy wondering about the world and trying to figure it out. And that's why also I speak to anyone that wants to discuss science with me without any status difference. And science is not an occupation of the elite, the way some people try to portray it. It should be a way of life. When I have a problem with a pipe at home, I approach it the same way that I approach a scientific problem. Anything in my life, I think about it as I do about scientific questions. And I think science is simple, and the public should be able to connect to it. And unfortunately, the scientists are very often distancing themselves from the public, trying to put themselves on a pedestal and say, we don't want to work on things that the public finds particularly exciting, like the search for extraterrestrial life. We want to feel removed and elevated, and it should be something that shows that we are really special. And again, it's the ego. And I have a real problem with that, because I think we should be guided by modesty. Especially as an astronomer, I look at the universe, it's so big and we are so small, and just 1 out of 10 to the power 20 habitable planets in the observable volume of the universe. It's just like one grain of sand on the landscape of a huge beach. How can anyone be arrogant? We live just for such a short time of the cosmic history. We are so insignificant, and why how can anyone feel power in being superior to another human being? I mean, that makes no sense. Racism, for example, makes no sense whatsoever. Just judging a person by the color of his skin, that skin deep, nothing significant about it. And we do a lot of things that make no sense to me. I mean, humanity doesn't show a lot of intelligence in the way that it deliberates itself. We waste a lot of time and money and energy on fighting each other when we should work together towards a better future. That's another message in my book, and I give some examples about that. For example, Winston Churchill, in 1939, he wrote an essay about the search for life and around other stars. That was 1939. He didn't have a chance to publish it because he was drafted to become prime minister of the UK and fought the Nazi regime during the Second World War. And imagine how many resources were wasted on killing people during the Second World War. If we were to use the same resources to study the question that Churchill posed in 1939, we might know by now whether we are alone. Instead, people just wasted that resource and killed a lot of other people, and nothing was accomplished. And it just shows you that we are not very intelligent. We are doing things that do not make a lot of sense in the big scheme of things. And that's one reason that I enjoy thinking about finding civil intelligence out there, because I don't find a lot of it on Earth.
That it's so refreshing to hear you talk, because as you've also covered in your book, where you have spoken about, and I want to just connect it to Oumuamua again, where in your book, what is the need for us to think that we would be visited deliberately by extraterrestrials? Do we give ourselves that? It could be just passing by, or they may not have noticed us.
That's right. I think we're not special enough to merit a visit. I think that we are probably quite common. Things like us existed and possibly exist right now in many other places. And it's sort of like ants on a sidewalk. When you walk down the street, you don't pay attention to every ant. So why do we think that we deserve special attention? Moreover, most of the stars in the Milky Way galaxy are dwarf stars. Like Proxima Centauri, the nearest star to the sun, has 12% of the mass of the sun. It's much fainter. It has half the surface temperature. It emits mostly infrared radiation. And most of the stars are like that. So most of the creatures in the Milky Way galaxy might have infrared eyes, not eyes like we have for visible light. So obviously, interstellar tourist agencies would not recommend the Earth as a tourist destination, because we have green grass that is illuminated by visible light, and most of these creatures are used to dark red grass using their infrared eyes to enjoy it. And so they would never come here. Just as an example. Another thing that may happen is that once a civilization becomes very advanced, it builds a cocoon. It has its own habitat that supplies the civilization with everything they need, and they feel happy there, and they don't need to establish contact with anyone else. And I call that social distancing on a cosmic scale. So you can imagine other civilizations socially distancing from us, not even caring about us. Now, that doesn't mean that we will never find about them, because they must produce some trash and throw it into space. And just like investigative journalists that go through the trash cans of celebrities in Hollywood to find out about their private lives, we can find the trash and figure out what they are doing.
True. And we do understand that you have limited time. You have another interview coming up. So once again, from everyone here, I would just like to quote the title of the book, which is Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. I've got a copy. I have to tell you that it's absolutely stunning. So before we let you go, once again, we've spent our time really well with you. I want to personally thank you for taking time out to speak to us here in India. And we just hope that you've had a good time as well. And would you want to give us a message to our listeners who are listening to you here? And what would that message be?
Yes, my main message is stay true to your curiosity, stay modest, just behave as if you were a child, and try to figure out the world honestly, and the rest will come along. You will make discoveries, you'll get important jobs in academia, and just be true to yourself. I should also say that many of my best collaborators are from India. One of them is finishing a textbook with me on the search for life. His name is Manasvi Lingam, and this textbook will come out in June 2021, in about half a year, from Harvard University Press. And it's about 1,000 pages long. It's very, very big textbook. And we hope that it will establish the foundation for research on this subject. Manasvi was my postdoc for a number of years, and now he has a faculty position. I'm also collaborating with other other Indian scientists like Hamsa Padmanabhan and Vikram Ravi and others. And I enjoyed it very much. And I think overall, India has a huge potential in terms of its talents. And I wish you success in the future.
So to all our listeners, this podcast was created on Hubhopper Studio. So if you wish to start your podcast for free, visit www.hubhopperstudio.com. Hubhopper is India's leading podcast creation platform, and you can start your podcast with Hubhopper Studio and get your voice heard across platforms like Spotify, Ghana, Google Podcasts, Wink Music, and much more. Do click on the link in the episode description or visit www.hubhopperstudio.com. Once again, thank you for listening, and do stay tuned for many more very interesting episodes.